In this video, I'd like to cover working with Alibre if you've never used it before. So this would be at least an Atom, a Libre Atom complete beginner's guide. I want to cover the tools necessary to make something like this. I've already made this on video, so you can watch that video after you've learned the basics if you'd like to follow along with me. We want to at least know all the tools that will come into making like this, and then experience would teach you how to use the tools in a way that you could be able to make something like this cylinder head. Likewise, this grill might be kind of fun, or know the tools on how to make something like this compressor. And I have an assembly over here. Assemblies aren't too hard, so maybe we'll be able to cover assemblies while we're at it as well. The annotated timeline on this video should be able to tell you what we're covering when. It takes a lot of time and effort for a video this size, and it was made possible by Brilliant.org. Brilliant is an online learning platform that has a lot of courses and quizzes on so many topics. This learning platform doesn't lecture you, but more guides your learning with interactive puzzles that illustrate the concepts. I've enjoyed the logic course very much. It starts simple, but teaches you higher levels of logic as you progress. But I love the approach of the Python course. Right off the bat, I learned to draw cool things like stars. I have one of those learning styles where I like to do the cool stuff straight away, and then I have a context for everything else I learn after that. That's how I run through things on my YouTube channel, and I find the same approach on Brilliant. Whether we're talking math, computer sciences, scientific thinking, I always find interesting problems to solve on Brilliant. Please use my personalized link to Brilliant, and the first 200 subscribers will receive 20% off. Click the link now to see what you can master on Brilliant. So let's get started. This is what Alibre looks like when you open it up after you first start it. Of course, you have your recent files down here if you've had any recent files open. And it gives you a few important options like creating a new part, creating a new assembly, or creating a new drawing. This video will be primarily focused on parts. Likewise, if you have any Alibre files, you can open them here. We can also explore, and this is where you find support, knowledge-based tutorials. It's pretty self-explanatory. And likewise, you have utilities over here, which we'll cover later on from different menus. So let's go home and create a new part. When you create a new part, a window like this pops up, and this will be the modeling user interface. When we take a look at this interface, we have just a few important elements. On our left, we have a history tree, and then we have ribbons, kind of like you would see in, Microsoft Word or something, where you have all these ways to make models from. From the view, I like to go here and make sure that my sketches and references are toggled on. Again, this is Alibre Atom. You can use this video for Alibre Design as well. There's just a few more options. So this is just how you want your model to appear. I like having all of these on, but I also like running pretty heavy. So ambient occlusion, ground shadow, model shadow, ground reflection, these are all things that just add a little bit of richness to the appearance of the model at the expense of a little bit of processing or graphics power. Okay, so let's go to model and we'll set up our files first of all. One of the main things for setup is to click on File. Let's go to Properties, and I have this little menu that comes up in Properties, and make sure that I am running the units that I wish to have. Right now I'm working in inches, and I can change this to millimeters if I wish. I use both. And you can have it show units for dimensions if you wish. I'll check that on. It's pretty handy to have. Under General, Saving, I think there's not too many other settings from here that I mess with. Although I do like having a nice fine facet resolution. Again, the more I move this to the right, the higher processing power my computer uses to give me a better image of what I'm modeling at the expense of processing. For all other settings, I can go into System Options, and I have a whole host of settings to go through, although I really feel that the settings that come with the Libre are pretty good. Ooh, shaded reference planes does look nice though, so I'm going to say yes on that. Okay, so we'll get into that. So here we have our default modeling environment. Now if I move my view, what I'm doing here is holding my left and my right mouse buttons at the same time. That allows me to roll my view as you see here. If I wish to pan my view, I'll simply hold down my center mouse button and move my mouse with the center mouse button held down, and that will pan my view. If I wish to zoom my view in and out, I simply roll my mouse scrolling wheel. You'll notice I have 3 planes, XY, YZ, and ZX. These planes, as you can see, intersect with each other, and there's one point where all 3 planes intersect. That's called the origin. And then, where 2 planes intersect, I have an axis. So I have 3 axes for the 3 intersections of my 3 planes. And then I have the planes themselves. So when we get into CAD modeling, these planes and axes and the origin are all quite significant. Anytime that we start modeling, we want to start with sketches. Let's go into how about the XY plane? I'll just click on my XY plane so that it's highlighted in blue. And I'm going to click on Activate 2D Sketch over here. Now, when we sketch, it is very important and fundamental to a Libre to be able to sketch well. To any parametric CAD modeling platform, you want to be able to have good sketching skills because that's how we make our solid models. Sketching is not the end product of parametric modeling, it's just a means to the end. So for example, how about I make a rectangle? This is not a very good sketch as it is, right? I just made a random rectangle. But let's look at what we can do with the sketch to turn it into something that's useful to us. So I've made a rectangle, which we'll talk about how to make much better in a few minutes. And when I deactivate my sketch, there's a few tools that I have to make my rectangle into a solid model. The first one is Extrude. I click on the Extrude button, and you can see I get a little preview, and this menu pops up. And I can extrude it, say, 10 millimeters. And when I say OK, our sketch turns into a solid, right? Now, over here in my tree to the left, I have my sketch in my tree, and I have my extrusion that I've made. And you can see that the sketch is kind of indented under the extrusion as the sketch is part of the extrusion that I've made, right? And so I can go back and change the way that my sketch looks. And as I deactivate my sketch, the part or the solid that I've created updates because I've updated my sketch. So I've got this little history of how I've made things over here on my left. And I can go ahead and delete the extrusion, and you can see my sketch remains. Now, as I've talked about, I've made a sketch on my XY plane, and I have this axis over here, which is known as my Y-axis. What if I highlight my Y-axis and I choose Revolve? Well, what if I just revolve this sketch that I've made around my Y-axis, and I add material as I go? If I choose Revolve, and it asks me what sketch do I want to revolve. I want to revolve around this sketch. And my axis, I'll revolve around this axis, right? And I've made this shape that revolves around this axis. You can kind of visualize it, right? If I make this, say, 1 degree. Whoops. And then I go to edit. I can kind of see the way that we revolve around this axis. I can go 40 or more degrees. So When we work with the Libre, we have these certain tools to change sketches into solids. And that's our goal as we begin to work with sketches, right? There are means to generate solids from. Now, not only do we have extrude and revolve, which we've seen examples of, but we have sweep, loft, helix, and then we have a bunch of subtractive features and a bunch of ways to edit our solid. So, as we begin turning our sketches into solids, we want to get good at sketches to begin with, because then we can make excellent solids. So I'm going to delete my elements in my history tree, right? And I'll choose my XY plane once more. And I'm going to choose to activate my 2D sketch. So first off, what tools do we have in the sketching environment? We're going to have the line tool, right? And I can just keep on clicking to make new lines that are all connected to one another. And I can make a weird shape if I wish. And I can highlight everything and hit the delete key to get rid of what I just sketched. So the idea is with the line tool, we make lines. With the rectangle tool, which we've seen already, we can make different rectangles. With the circle tool, right, I can make circles. This is pretty straightforward. If I click on the arc tool, I click on a point that will be this exact center of my arc. I choose a point to start my arc with, and I choose a point to end my arc with. And that's how I generate an arc feature. Tangent arc is very similar, which I think we'll have to go through in a little bit. Ellipse is pretty cool. I click one point to center my ellipse. I click one point to find the end of my ellipse, and then I click on a third point to choose how eccentric I want my ellipse to be. And from here I have 2 points, a point there and a point up here, and that gives me a nice little method to dimension things with my ellipse. Next, I have a polygon, and when I select my polygon tool, I can choose either this profile or this profile. You can have the same kind of polygon with both. There are just different ways to define it. Do I want my circle to be on the insides of my lines or on my corners? This might be nice for beginners, so I'll choose this. I'll choose 6 sides, and there I can make a polygon, or what Tim Allen on Home Improvement liked to call a 6-sidagon. I can make this as small as 3 sides and draw a triangle, and I click apply, right? So we can make different polygons that are really nice. Now you can argue that you can make 6 lines into a polygon, and you'd be right. You could make this without the polygon tool. This is just a way to save time. Next I have a spline. This can be a little bit intimidating for people, especially people who wish to define their sketches, which we'll get into. But a spline allows us to generate smooth, organic shapes that would be hard to make with the other tools that I've just shown. So those are the main sketching tools that we have to work with. Let's start with making a line. I have a similar video to this where I cover FreeCAD. So here I've used my line tool and I've made a house shape, just like I've done in my other FreeCAD video. And with my house shape, you'll notice that I can click and drag my lines to different positions. This is not ideal, right? We want to tell a Libre where all of these positions are. And we can do that using the help of the origin. So I can tell a Libre that I want this line to be, let's say, 12 millimeters long. I simply grab the dimension tool, click on the line, and choose 12 millimeters. And now, no matter how I manipulate my sketch, I cannot change the length of this line. So when I give it a dimension, a Libre makes sure that that dimension will always be 12 millimeters. Now, you'll see that this line is turned orange. That means that the magnitude has been defined, but the position, right, where the line belongs, is undefined. And I can use the origin to help me identify what position I want. So I'll grab my dimension here, and I'll grab, say, the tip of my line here, and I'll say from my origin to the tip of my line, I want the horizontal distance to be 4 millimeters. And when I hit the Enter key, and I'll hit the Escape key once to get out of my dimension tool, now the end of my line stays 4 millimeters horizontally away from the origin. But I can still adjust my vertical dimension. What if I want it to be directly even with my origin? Well, I have something known as constraints and relations, so it's not just dimensions that I use when I sketch. I'm going to choose the horizontal constraint tool, and I'll choose, say, the tip of my line and my origin. And when I do that, you can see that now, and I'll hit the Escape key to get out of my horizontal constraint tool. Now I cannot manipulate this line whatsoever. And that's because this line has turned black and is now fully defined. That is a good goal for just about every sketch you'll do in CAD, with a little bit of exception in certain cases. So this line now knows that this tip should be 4 millimeters away. I use my horizontal constraint to tell the line that it should be horizontal with the origin, and I use my dimension constraint to make sure that it is 12 millimeters away from the origin. So this line is fully defined. Now what about all of these others? Well, we can use dimensions and constraints to tell a Libre what to do. So what kind of constraint tools do we have? Well, you can see that there are some of these little gray guys that are showing up already. These are known as auto constraints. So if I draw a line that is vertical, you can see that I have this blue auto constraint that shows up. And I have a blue auto constraint on this other line over here. That's no accident. That means that should I click to create the line, it will automatically be held parallel to the other line that has the blue symbol showing up to it. So that is known as the parallel auto constraint. Now if I move this line horizontal, I have this little right angle looking square thing. That is the perpendicular constraint, right? So perpendicular means that it will be held at 90 degrees to that line all the time. Likewise, if I move it at this angle, you can see that a Libre knows that the parallel constraint shows up if I move it parallel to a line that already exists in the sketch. So if I define this line and hit the Escape key to exit my line tool, now however I manipulate the sketch, it will keep these lines parallel. Very, very handy. So sometimes you have these constraints that show up automatically to help us save some time and effort when we go to sketch. So I have auto constraints, and we've covered what parallel looks like. And likewise, if I have a line and I want this line to be parallel, I can highlight these two lines here. And notice when I click on one line and click on the other, it of course clicks off the previous line. So I hold the Shift key to highlight multiple things at the same time. And with the Shift key depressed and I highlight both of my lines, I can choose this parallel constraint up here, and it will add to make sure that both of these lines now remain parallel, no matter how I manipulate the sketch. Of course, I can always highlight this line and hit the Delete key because I don't actually want it. Another important thing to add is an equal relation, right? What if I want the two walls of my house shape to be equal with each other? Then I can hold the Shift key, highlight these two lines, let go of the Shift key, and hit the Equal constraint button. And now I'll hit the Escape to get out of my Equal tool. Whatever I do to my sketch, these lines will always remain equal. Likewise, I can hit the Equal constraint, and I can highlight this line, and these will be made to be equal always. So you can click on the tool and click the things you want to be equal or parallel or horizontal or whatever, or you can pre-select them by holding Control and then clicking the button up here. It works the same either way. Great, so those are some things that I can use. What other tools do I have? If I have a line over here and I highlight this line, I can choose horizontal, and that will make sure that my line, no matter how I manipulate it, will stay horizontal. I can draw a line and make it vertical. Right, I choose my vertical tool, and now the line is forced to be vertical. Likewise, I can make a line, and let's say that I want my end of my line to always be located along or in alignment to another line. Well, I can choose coincident for that. So I choose this little coincident button up here, and I choose the end of my line, and I choose some other line. And what I've done is that now the end of my line will always be in alignment with the line that I've chosen. That's coincident. Likewise, let's say that I've drawn a line and I want to fix this endpoint onto this endpoint. I can choose coincident and choose here and here, right? And now, no matter how I manipulate my sketch, I will always have these lines be coincident. The key thing is I always hit the escape key after using my constraints. So I make a line, right? I add a constraint of some kind, and then I hit the escape key to get out of that tool. Otherwise, the Libre will think I'm still wanting to continue to add constraints using that same tool. All right. So how about we fully define this? I get into my dimension, right? I choose my dimension tool. I'll add a vertical dimension to give my wall a height of, say, how about 10 millimeters? What if I want to choose an angle on my roof, right? What if I want my roof to be like 45 degrees? Well, if I click one line and another line with my dimension tool, I can choose a degree angle of, say, 45 degrees. And now if you notice, my whole sketch is black. That's our goal, to fully define every part of our sketch. It should be black. So we're all done when the sketch is black. Now, I've shown how to do an angle with a dimension, and I've shown how to work with the lines. But what if I get a little bit more complicated, right? What if I delete both of my lines, what if I want to have a smooth curve that goes along the top of my roof? Well, I can make sure that my lines are equal so that they'll always have the same length, and I can make sure that the two ends of my lines are horizontal, and that will ensure that however I manipulate my roof, the equal and the horizontal makes them somewhat symmetric, which is pretty cool. But if I want to add a smooth arc, I have to use my arc tool. Now I've shown how to make a 3-point arc. Right? I choose a center for my arc, and I choose some lines, right? And I can just sketch an arc out that way, as you've seen. But maybe this is a good time to show the tangent arc, right? So I choose my tangent arc, select a point, and then I choose the second point. Now you'll see as I manipulate my arc that I remain what's known as tangent. Tangent is a nice feature because if I draw an arc like this, you can see that there's an abrupt transition between my line and my arc. So if I hold Shift and I select both my line and my arc, I can change that to be a smooth transition by choosing tangent constraint. I choose a tangent constraint, and then Libre makes sure that my arc smoothly transitions into my line without any sharp edges. Likewise, I can choose coincident to fix the end of my arc onto my line. And I think by the way that my geometry is worked out, I don't need to worry about adding a tangent on this side. In fact, if I try to add a tangent on this side, I get what's known as a constraint cannot be applied since it results in an over-constrained or inconsistent sketch. If you come across this error, it means that you have more than one thing telling the sketch how to be. So in other words, if I try to say that this line right here is 10 millimeters and this line right down here is 12 millimeters, and I go into my equal tool and I tell my lines to be equal, then it says, oh, it's over constrained, meaning this has to be 12 and this has to be 10, which means that they cannot be equal to each other, right? I have multiple settings that are conflicting with one another. So as we go about in Sketch, it's important to remember that we want to do so in a way that it doesn't over-constrain anything. We give one definition to everything. And if that's overwhelming, just think that that will automatically pop up if you try to over-constrain. So it's not something you have to worry about. Okay, so we've done this. Now let's say I want to add in a circle for some reason. There are some constraint tools that I would like to cover that cover how to work with circles. One of my favorites is concentric. So concentric means that two circular things will share the same center. Here I've got a little dot that shows the center of my circle, and here I've got a little point that shows the center of my arc. And if I choose concentric on both of these, it forces them to share the same center, which really is actually kind of cool. Maybe I'll leave my circle there. Next one, this is a coradial constraint, which is a lot like concentric. So if I draw an arc, right, coradial just means that these arcs will share the same radius if I apply that tool. So I'll choose coradial up here. And now that means that they share the same center, like concentric, and the same radius. Also, just by hovering over this, you have a pretty good explanation. Okay, so it's coradial and concentric, and then we have a simple intersection. So if I make an X kind of shape out of my lines, you'll see that there's no real point where these lines intersect. But what if I wanted to draw a circle right where these points intersect? There's no point to draw it from. So if I drew my circle, and I wanted the point of my circle, whoops, and you'll see I can't move this circle freely because I've had an automatic constraint show up. So I click on this little automatic constraint and I hit the delete key, and now I can move my circle around. Let's say I want the center of my circle to be at the intersection of these lines. Well, I choose my intersection constraint, highlight the center of my circle, and highlight where the two lines that intersect There we go. And now my circle is held at the intersection of these lines. And as I manipulate these lines, you can see the circle stays intersecting. So that is the intersection constraint. It's not used as often by me. So we've got perpendicular, parallel, I think we've covered equal, basically all of them. Symmetric is a little bit more advanced, but it can be a lot of fun. Let's say that I have a circle and another circle, and I want them to be symmetric about this line. I'll choose the symmetric constraint, and I'll choose the point of symmetry, here this line, and I can choose one circle and another circle, and then I'll hit the escape key, and I've made it so that these circles, no matter how I manipulate them, are symmetric about that line. So that's really handy if you want things to be symmetric and constrained in a way that they're predictable about a certain line. I think that is, midline constraint, right? So let's say that I have this line and I want this point to line up right at the dead middle of this other line. Well, I can choose the midline constraint and choose my line and choose my point, and it automatically knows that this line should be in the dead center of this other line. So no matter how I manipulate it, it will always end up as being dead center. So those are all of the constraints and relations that we've gone through, all of them that are available. So let's fully constrain this sketch with some of those tools. Let's make this 2 millimeters, and maybe relative to this bottom line, I'll make the center of my circle, let's say 15 millimeters high. And then if you're wondering, like, well, I've got a line here, you can always click and drag and see where you're not constrained. So grab a red element, click and drag if you're confused how to constrain it, and clearly you can see the diameter of the circle is not constrained. So I grab my dimension, we're going to say, how about 2 millimeters? So that is how we can sketch. So let's go through just kind of a further example of how to do this, because it sure can be confusing to learn sketching if you've never done it before. Maybe I want to grab a tangent arc, and then maybe I want to grab a regular arc, right? So if I want these to be tangent, I could have just drawn a tangent arc, but if I have two arcs that are not tangent, I can use this tangent tool to make them tangent to each other. Likewise, I can make this arc tangent to the line. And now I've got a kind of a wavy roof that has smooth transitions all throughout. Likewise, maybe I can delete this and do the same thing over here. Tangent arc and a tangent arc. Now I want my roof to be symmetric, and there's a lot of ways to make it symmetric. So with CAD, it's less about what is a way that I can do it, but it's really choosing the right way to do it. And because you're the engineer, you get to decide based on your design intent what the right way is. So I can make this symmetric in many ways, but for the purposes of this demonstration, so I can introduce some new tools, let's talk about these dotted lines and circles, right? If I choose this dotted line, and I come over here, and you can see as I highlight this, there's a little dot that shows up in the middle of my line that highlights the exact center. So if I click on that little midpoint, then I know that I have the exact center of my line. Well, now I can make this vertical, right? I can make this dotted line vertical, and that forces the circle to be in the exact center of my house. Well, this dotted line is known as reference geometry, right? Reference line. And what that means is it's something that I can refer from, but it's not actually part of the defining geometry of my sketch. In other words, when I make this a solid, I am not going to have some line going through the middle of it, because this is just a reference line. It's not a regular line like this one is. So I can use this reference geometry to kind of reference from and not have to worry about it changing the geometry of my finished sketch. Let's make these equal now. I'll choose my equal tool and make these arcs equal. And then I'll make this arc and this arc equal. And then I think, well, I'm still not fully defined because I have red and orange. So if I click and drag, it becomes a little bit more apparent that I say, oh, I've got a sharp transition from this arc to this line. I want to get rid of that transition, so I'll choose a tangent. Likewise, I can click and drag again. I can say, oh, you know what? I don't have a full radius on these lines, so I can choose my dimension tool, click on my arc, and I can set a radius of, say, 6 millimeters. And what if I want these to have a radius of 6 millimeters down here? Well, then I can choose equal and give them both a radius of 6 millimeters, and that fully defines my sketch. Everything is black. So a nice troubleshooting tool is to say, I can click and drag things, and in the ways that they are free to drag, I can use dimensions and constraints to stop them from being free to drag, right? So let's deactivate the sketch now. I just click deactivate sketch, and I can extrude this, and just as before, it extrudes my shape. And because I have my hole, I know that that it's going to not extrude where I drew my hole. Likewise, I can get back into my sketch by right-clicking it in the tree and saying Edit. And I can add anything else, right? I can add a little ellipse into this shape. But I'll move this ellipse down a little bit so that I don't interfere with my hole. If I deactivate my sketch, right, there's my ellipse. Now, of course, my problem with doing that is I just drew an ellipse without defining it. It is best practice to make sure that my ellipse is black. So I can add, say, a dimension here on that little handle it gives me. I can add a dimension here on the handle it gives me. And now I'm fully defined. We'll deactivate. And there's my house shape, which I think is pretty cool. So that is how to sketch. So we've covered using the dimension, using the line, the rectangle, the circle, the arc, the tangent arc, the ellipse, the polygon, a little bit of the spline. We can also add text to our sketch, right? If I type out house here in all caps, you can see that my text is quite large. And so I can highlight my text and make it something like 10 millimeters, a little bit more manageable, but I should be smaller still. So if I accidentally hit escape, as I've just done on purpose here, I can always double click on my text and it brings up my editor again. Maybe I want to make this 1 millimeter, right? And then I can position my text with my little center handle, and I can define it how I want to, right? I can choose my little, well, let's choose coincident up here. And I can choose my little handle. And it tells me that I've already made the coincident constraint, so that's good. What if I try to dimension something, right, from end to end? That will tell me that I'm already dimensioned, so I can only select a dimension that will have parentheses around it. What does that mean? That means that that is a measurement that is not telling the sketch what position it has to be in, but rather telling me what the measurement is without defining anything. In other words, if this didn't have parentheses, it would be trying to tell the sketch that it needs to be 4.564 millimeters wide, but we already have other settings that determine how wide the sketch is. So it is what's called a driven dimension. Likewise, I can define a height here. Let's make it 3 millimeters high, and we're fully defined. So likewise, if I try to dimension a line that's already dimensioned, I'm given a driven dimension. And now I have my driving dimension that doesn't have parentheses that I can edit at any time, and my driven dimension, then if I try to edit, I can try to make it a parameter and it just doesn't work, right? So I'm going to get rid of that. So if the dimension has parentheses, it is simply telling me what the dimension is, but not defining anything, right? And that's helpful, because what if I want to take a measurement from this point to this point? I can, and it tells me without trying to overdefine my sketch. Alibre does a very good job at making sure that you don't overdefine things. Of course, I've manipulated my sketch in a way that has messed things up, so I can hit Control-Z, and I can keep hitting Control-Z until they go back to how they were. All right. So that is Sketch Tools. It takes a lot of practice to be able to sketch well. So please don't be discouraged if it takes a little bit of work to figure a sketch out or what you wish to sketch. So as I deactivate the sketch, you may find that you may be asking yourself, well, how come I'm not having the house figure show up? And it's because I have text within a closed figure. I did this on purpose to show, in case you run into this too. Having text within a closed figure can be complicated, right? So if it doesn't work, we're just going to take our text out, and we can add the text in a secondary operation, right? We're sketching on the XY plane. What if I chose my XY plane and chose Activate Sketch again? Now, let me take my text. I'm going to say house. Maybe we can make this, I don't know, 5 millimeters. We'll say apply, and then I'll double click on my text. Okay, like 5. That's still big, isn't it? 1 millimeter. Okay. So take my house text, and I should fully constrain it. I'm just going to give it a few random dimensions of like 10, and then give this a vertical dimension of, say, 5. And I deactivate my sketch, right? Now I still have my text. It's not showing up for graphics reasons, but I can cut my text by choosing this extrude. Not this extrude over here, but this extrude that's made to remove material. And I can move my text into a depth by dragging this arrow, or likewise in the menu that pops up over here, I can specify something like 2 millimeters, right? And then I've got a 2 millimeter deep house, what we think of as a pocket or an extruded cut. So this extrude adds material. This extrude over here takes material away. And you'll see that theme through a lot of these tools. So if I try to say I want to cut through all, I certainly can do it. And CAD is very forgiving. But you'll notice I've got this little body that's floating in the middle here that's not connected to anything, right? So if I take my view and I look at it straight on, this little O center is just floating in space. So it might look right, but a few considerations to think about with CAD and how realistic you actually want it to be. So I've got my house over here. Things are looking good. How about I save this part off as like a little sample part, and I can put it into GrabCAD. So if we want to save something, we say File, and we can say Save or Save As. I can always take this window down, even close it after I save, and we'll create a new part. In this part, let's look at a little bit more sketching skills. Perhaps I'll highlight my XY plane and activate a 2D sketch as before. Let's make maybe some kind of mechanical ring. Let's start the sketch with our mechanical ring. Something like this. Hey, that turned out pretty cool. I'm pretty good at winging it. All right, I'll grab this line. We'll give it a little vertical, right? Now, how else do we want to constrain this? Let's say we'll go with a horizontal from this point to this point. And then let's give it a horizontal from the origin over to this point, right? And maybe I'll give this a dimension. Whoops. A dimension of, Oh, this one is in inches, of course, because I think that's what I'm defaulting to. 1.5 inches, how about? Give this a dimension of 1 inch. I think I'd probably want these lines to be parallel. So I choose my parallel tool and click both of these lines. And then I'll choose equal, and maybe I'll make these two lines equal at 1 inch. But the constraint already exists, of course. All right, maybe I can add an equal from here to here. You know what? I don't like that. Control Z, the easiest way to get rid of equal. Let's come over here and maybe make this 0.5, right? Something smaller. Maybe I'll give this an angle of like 45 degrees. And now, notice all the red is gone, right? And so that tells us we just have a position. What do I want the radius of my ring to be? Maybe I'll choose the origin and my absolute interface and maybe make that 10 inches, right? So I have a 20-inch large ring. Now everything is black, we're fully defined. Let's go to just a few other new sketching skills, right? Everywhere that I have lines that intersect, I have sharp angles. Here I can add a fillet. And when I click on this fillet button, I get this little figures to fillet that comes up. And we are defaulting at 1/2 inch. I'm going to make that 0.125 or 1/8 of an inch. And I want to choose, say, this line and this line, and I click apply, and it automatically adds a fillet in the sketch for me. That's a nice feature so that I don't have to worry about adding a fillet after the fact. I can choose this line, and I get another nice little fillet, right? So I can make every edge, if I wish, have this fillet and do so way more quickly than trying to sketch out all the different little arcs that I have to sketch out. Now you'll notice on that last one, I did the fillet, and all of a sudden I've got red and oranges, and I can click and drag and verify that, yeah, something happened. So I'm going to hit Control Z, and usually what happens is when I add in my fillet, and that happens, I lose some kind of constraint or relation, and usually something related to the fillet that I've added. And if that happens, that's okay because I can reconstrain. The question is, what did I lose and why? I go from here to here, and I add my fillet. Yeah, there's some kind of dimension that I'm losing. I think it's probably an equal somewhere. Regardless, I can use a dimension or another constraint and simply reconstrain everything. 3.5 is what it was. Looks like a great dimension. So that is the basics of using the fillet command. And there again. So that happens sometimes. And I think that happens in most, if not all, platforms. It looks like when I added that, I had a little horizontal. Let me back up. I had this little horizontal right here. And you can see that when I hover over this horizontal, it makes this point blue and this point blue, so you can see exactly what points are horizontal. And when I add my fillet, Libre goes, okay, when I add this fillet, this point has to go away. And because this point had a constraint on it, the constraint went away with the point that went away. So I simply re-add, the part that was lost. And we're good to go. Except, we've got a little bit more that was lost. So in this case, it probably doesn't hurt to keep on adding these fillets in areas that we might think we'll lose a bunch of constraints and relations still. But there, we've been able to smooth out every corner pretty easily. So we'll grab this, maybe we'll add a dimension on this line, and really, I would say it's better form to choose the arc centers and just in terms of engineering, right? 0.75, there we go. Let's go over a few others, right? What if I have a line that crosses another line? And I just want, one side to be trimmed and stop at the line that's being crossed. There I choose my trim option, right? And I can just trim off where I want things to be gone. And when I do, you can see that it just creates a point of a coincidence. And it stays coincidence. You've got a little coincident relation on there. All right, excellent. Finally, extend is kind of the same thing. It's kind of an easy add, almost coincident-like thing. Or if I choose extend and I choose my little point, I can choose a point that I want it to extend to. And these things automatically extend to the next points. And again, they're held coincident, right? So a nice little time saver right there. Finally, you can do that with 2 lines if you wish, right? These are just little time savers. You can do the same thing with these constraints if you wish, but we can just choose 2 lines and have them intersect together and be held coincident at their endpoints. So those are some additional tools now that we've had a little bit more practice with sketching. Okay, let's do a revolve to finish up our mechanical ring. We'll deactivate our sketch and we'll choose the revolve command. We'll select our axis. I can choose it from the graphics display here. And there's the preview for my ring. I will say OK to make it so. So that will be our revolve now. Now that I have this ring, let's go over a few other things that are going to be just useful. I'm going to go into my tree, find my sketch. I'm going to right click and edit my sketch. Maybe I want to offset my sketch. As I edit my sketch, I'll choose offset. And I can offset all of these points. Now I'm going to go kind of thin. Let's go with 0.05 or something like that. And then I'll continue to select these parts. And I don't have to go all the way around if I don't want to, right? But offset lets me simply choose sketch entities that are a specified distance away from what you've already sketched. So I can make this 0.5, or I can continue to offset higher and higher. Now as you offset, you'll see that my fillets right here, they get so big that they have to collapse into nothing. So good on Alibre for being able to deal with those fillets effectively, right? But here I have an offset that I still have to add my constraints and relations to, right? They're not constrained in any way. But I can offset this if I wish, which is a great tool to have. Likewise, I just clicked them one by one to show you, how it goes, but I can highlight all this and choose my offset. 0.05 was actually pretty good. You can see that we've been able to offset it pretty well. So let me fully constrain this. And if you haven't had a chance already, I'm going to fast forward this to not waste time because it really is going to take a long time to do this as far as just viewing this is concerned. Try fully constraining this yourself. And then I'll see you after I'm done fast forwarding. All right, we're fully constrained now. Now, if you had trouble, all I did was I took all the horizontal lines and added the horizontal constraint, all the vertical lines and added the vertical constraint, and then I took all the diagonal lines and made them parallel to the other diagonal lines that I already had, because we know we want all these to be parallel. And then I took all the arcs and made them concentric to the other arcs, and then I added one dimension, 0.05. I can make it 0.025, right? And then the whole thickness updates. I thought that that would be the best way to define it, because then you can change the whole thickness on one dimension, which would be the design intent that I would be going for if I were to edit this in the future. But there's no right or wrongs. You can change the intent based on what you see fit. But hopefully that was kind of a handy exercise to think about how things are fully constrained, and if that was handy or not. So when I go to update this, right, I deactivate my sketch, and my solid updates to match what the sketch was, and you guessed it, we should have a hollow part. So if I edit my revolution and make it go 180 degrees instead of 360 degrees, right, we should be looking at something that is hollow, which should be kind of handy if you want to make something like that. I think that'd be hard to make in real life, but hey, that's pretty cool. So those are some sketching exercises where we can use the offset and some of the other like fillet type commands in the sketch to speed things up and make it more easy. So we've covered extrude and revolve. And then we've got sweep, loft, and helix. And all those are pretty intense, especially the loft, which gives us a lot of functionality to be able to work with. So let's save this. And then let's work on modeling the next thing. Let's make a sweep. So I'm going to close this down. Let's create a new part. This will be the new part context here. What is a sweep? Because so far we've covered an extrude, which pushes something out of a plane, as you've seen, right? If I want to extrude a hexagon, I take my polygon figure, I could take my horizontal, I could take my dimension and make it like, I don't know, an inch. Deactivate the sketch, and as I extrude it, you can see it's just being pushed with that profile straight out of the plane. And when I revolve something, I can just revolve that profile straight around an axis. So what is sweep? Well, how about I keep this little polygon or six-cytagon figure? If you needed me to slow down when I made that, right, all I did was make this top line horizontal, and then I gave this a dimension of 1 inch. I'll take my ZX plane now, and I'll activate a sketch on my ZX plane. It is important to select the correct plane on both sketches. So I make a line, and maybe I'll make a tangent arc. I really like tangent arcs because they save me a lot of time. And you don't have to make the sketch that I'm making if, I don't know, you can just do your own thing. We can make whatever path we want, and I'll choose the tangent and make sure that I am tangent at all of my transitions here. Alright, yeah, looks like we're tangent there. And tangent there. No, looks like we're not tangent, so I'll add a tangent. There we are. And then let's start giving this dimensions, right? Let's make this, say, 4 inches. We'll give this a radius of, say, 2 inches. We'll give this arc a vertical dimension on its endpoints, let's say 0.5. I'll make this have a radius of, say, 5 again. Ooh, that's a big radius. Like it. Let's do this relative to the origin, right? You can do whatever you want on this. Let's say 6.5. Maybe we'll give this an angle. Looks like it... yes. My angle is a driven dimension. I overlooked that because I was thinking 3 steps ahead of what I was doing. Let's get rid of this angle. Let's get rid of this dimension, right? I can also define this by an angle if I wish. And we can make that, say, 50 degrees. And then this line is, this arc, I should say, is defined as well. I can give this a distance. 5 is good. Let's give this a radius, say 3. Give this a distance. Maybe we'll make it really long. We'll say 10, right? So I've made this kind of crazy little profile up here. You can download this from GrabCAD if you'd like. I'll post all these on GrabCAD. And you think, what would I be doing with this hexagon profile and this big path that I've made? Well, we're going to choose this sweep button. And on this menu that comes up, it asks us for a sketch to sweep. I'll choose my hexagon profile to sweep. And on my path, I'll choose this path. And as you can see, it fills in the path with the profile that I've made. So we can sweep entire path, or I'm going to stick with entire path because I don't have any geometry to sweep to. And I'm going to say OK on that. And I've made a nice little sweep with my model. So you can think about that's how you would make like hood pins on a muscle car, or all kinds of different things. Sweep is an extremely useful tool. And it all starts with just one profile sketch and one path sketch, right? Easy. So that is how we do sweep. Next, why don't we take a look at Loft? And Loft is a highly developed feature that Alibre has. It is incredible. Alibre has done such a good job with lofting. I love using it and I'm very impressed by it. So, in order to do Loft, we have to go through our reference geometry a little bit. Let's save this first and foremost to make sure that you'll have something to download from GrabCAD. So I save that as sweep. And the GrabCAD link to download this stuff will be in the description. We'll delete everything in our tree so that there's no features or sketches. So right now we have these planes that all intersect at the origin. And we've been sketching on these planes. But we don't have to have these be the only planes that we sketch on, right? We can make our own planes. So how about I highlight my XY plane, and I go to this little plane menu here, and this menu pops up, and I can choose a distance to make a new plane that is parallel to the XY plane. I also can choose this little reverse, and you can see how my new plane reverses if I wish. So I'm going to make this, say, negative 20 inches away. And you just have to choose an existing plane, right? You can choose a face of an edge of the solid that you're working on. You can choose an axis, and you can rotate a plane around that axis relative to a reference. There's all kinds of ways. One of my favorites is to choose 3 points. There's all kinds of ways to make planes. So hopefully we'll have some time in this video where we can go through all the methods to make planes with. As of right now, I've created a plane, and I would like to sketch on that plane that I've created. And let's choose a polygon, or as Tim Allen calls it, a 6-sideagon, but let's make it instead, how about a 3-sideagon? And I'll make my triangle. I think that looks like Harry Potter and the Deathly Hallows or something like that. And I'll choose a horizontal constraint and make my line horizontal. And I'll choose a dimension, and I'll make this something like 10 inches. Deactivate that. So I've got a triangle sketch on my one plane. Let's choose my XY plane and sketch on my XY plane. We'll choose a circle, and maybe I'll make it about that big. 6 inches, right? Good size for a circle. We'll deactivate that. So I have a circle and a triangle. So what I'm going to do is I'm going to say, I've got my circle, and I want it to go to where the triangle is. And as I want my circle to go where to the triangle is, I want it to gradually turn into a triangle from being a circle. And that's what a loft is, right? So I click on my loft, and this menu comes up, and I choose my circle, and you can see my sketch comes up here, and I choose my triangle, and there I have a circle that slowly transforms into a triangle. It's brilliant. I say OK, and there's my loft. Now, I didn't do it exactly the way that is best to do when I loft. I broke a rule. But Alibre is so forgiving, you probably would never know that I broke a rule from looking at it. But if you have a very complicated loft, and you have to troubleshoot that complicated loft, it is worth knowing the rule that I just broke so you can troubleshoot it and find solutions to what the problem could be. The rule is I have a circle, right? A circle is a single sketch element. And I have a triangle, that's 3 lines. That's 3 sketch elements, right? So I've gone from 1 sketch element to 3 sketch elements. And that's the rule that I broke. You don't really see a problem with it in this particular loft, but when you have complicated lofts that have problems, the number one thing you should check first before anything else is your number of sketch elements. So I want the circle to be 3 elements instead of 1 element, but that doesn't mean that I draw 3 circles. That doesn't make any sense, right? So what I can do is right-click on the circle and convert to a reference figure. And if you recall, the dotted lines mean that this is not actually defining the geometry of the model, it's just there for reference. So if I deactivate my sketch, right, I don't have a loft anymore because I got rid of my circle, and I get this little error message on my loft. See that little X by my cursor? And if I check my status, it's going to say invalid parameter was passed to the function. That just means that my circle has a problem. So let's go back into my sketch by editing it. But I still have my reference circle. And so I can take my arc, and look at that. I can make 3 arcs over my reference circle. And that should be excellent, right? I'll take my horizontal, and I'll make these points horizontal. I'll take a vertical, and I'll make this point vertical. Now, for really good form, I want the angle from these points to all be 120 degrees apart. That means that every arc goes 1/3 of the way around. Well, to do that, I can use my reference line. So I choose my reference dotted line up here, and I draw from here to here. I'll choose my dimension, and I'm going to make the angle between these 120 degrees. And now we're fully constrained because of the constraints that I've added. So I'll deactivate my sketch now. As you can see, we're looking very sharp, very good. So that is lofting, but there's a lot of options associated with lofting that we haven't covered yet. For instance, if I edit my sketch and I make my circle have a diameter of something like 2 inches, right? I make it substantially smaller. That'll exaggerate some of the things I'm about to do. You can see I'm going almost on a straight line basis from a circle into a triangle. But what if I want the triangle to be kind of normal to my profile or come straight out from my profile, right? Well, that can be an important thing to do. So if I edit my loft, my triangle, of course, is sketch number 1. So I specify tangent to sketch number 1, and you can kind of see perhaps you didn't see any changes. It looks much the same so far. Well, let me add a magnitude, right? So I choose my tangent magnitude. Let's make it like 3. And you can kind of see now that my profile changed. And maybe I can up it to something like 10. And as you can see, it makes it more triangular. So now, especially if I take a side view, which I have some view icons up here, I can view the side. And I'm normal to my plane as I go into it. That's what that setting does. And I can do the same thing if I edit my loft again by specifying a tangent magnitude on my circle. And maybe I'll make my tangent magnitude 3. You can see that I can change this profile. I can make them both 10. And I can change the way that my profile looks. All right, that's actually really cool. I really like that. So that is one of the most important options for me when it comes to lofting, because it makes life so easy to be able to go do this change. Likewise, if I go to my loft, I say edit. I have a few other options that I can choose, right? I can change my twist minimization to none. And you can see it kind of breaks the model there. Choose my center of gravity or distance, right? Honestly, I almost never touch twist minimization. I can choose minimize curvature. And you can see that tries to keep my tangent values, but with doing it with as little curvature as possible. So that is something. I can try to simplify, which often doesn't do anything unless you have an unusual model. You can choose ruled, which ruled is again just that straight line profile. And I can choose something that produces no new vertices, which again, because we have gone from the same number of elements to the same number of elements, really takes all that uncertainty out of the equation. But that's also a way to troubleshoot if you don't have the same number of elements for some reason. No new vertices. So we can say okay to that. But are we done lofting? No, we still have more things that we can do with lofting. Why? Because the Libre has made a lofting very, very powerful. So, what else can I do? Maybe I'll get rid of my loft for now. And I can select this plane, and I can activate a sketch. And I can choose an arc. And I want my arc, I want the center point of my arc to be horizontal to its endpoint here. And then I want to be able to reference, say, this line here, but as you can see, I can take, an arc and I can reference anything along this arc, but I can't reference my sketch. So what I can do is import a part of my sketch into something that I can reference. I want to reference this because the end of this line is the exact center of my triangle, and I want to reference the center of my triangle. So I'll project a sketch here, and this menu comes up. So I can choose to either create a sketch figure or create a reference figure. I want this to be reference. And I'll choose an entities to project. I'll choose my line. And then do I want it to maintain association or not? I almost always want it to maintain association. So if you ever forget what this does, just choose maintain association, and I'll show you here. So there is my reference line with maintained association. Now, I can choose project a sketch. I can choose this entity, and I can choose create a sketch figure without maintained association, right? The other two options. And because I don't have it maintained association, notice I can't manipulate the imported element at all because I've maintained association. But without maintained association on this element that I just made, I can manipulate this thing however I want because there's no maintained association. And you'll notice that this is solid, whereas this is dashed, right? The solid comes from it being a sketch figure instead of a reference figure. So I'm going to delete that, and that's the general guide on how to import sketch elements. Now that I have the sketch element projected, I've got this like point that marks the center of my triangle, and that's what I want. I'll make another arc, and I'll also choose horizontal. I'll choose equal so that these arcs are of equal radius. I'll choose a tangent arc. Looks like that tangent arc doesn't want to go actually, and that's fine because this arc will work just as well. So I'll put in a 3-point arc, and we'll choose tangent. Tangent, and everything else is tangent. All right. I'll choose a vertical, right? I want these points to be vertical. Apparently that's already applied as well. And so as I manipulate this, it looks like I just need some radius values. I'll go dimension, and I'll choose this radius value here. 20 is fine. Choose a radius value here, maybe 15, right? So now I've got this little swoopy line. We'll deactivate our sketch. So now what if I say that I want this circle to slowly turn into a triangle, but instead of just going in a straight line, what if I want it to follow a path? Well, I'll choose my loft, I'll choose my circle, I'll choose my triangle, and then notice I can't see my other sketch anymore. I'll choose guides, and I'm going to choose for right now a global guide. We'll go through these. And I'll choose my, not my global rather, but my center line. And you'll see that I've got my wavy path now. Isn't that something? That is pretty cool. So when we wish, we can choose a center line that acts almost like a sweep path in a way to go from our circle to our triangle, because it's like we're following a sweep path, right? Except as we follow the path, we're actually changing profile. So you can imagine the huge amount of usefulness and power you have over being able to use center lines. And we have the same options. We can minimize curvature, which is not very applicable. We can simplify. Again, we're choosing things that aren't that applicable. If I choose ruled, it gets rid of my guide, so we'll not choose ruled. And no new vertices again. That's not too much of an issue because we've done it right in using the same number of sketch elements. We can minimize twist in various kinds of ways, but again, I always leave it on how it is unless I'm having some weird problem with twist, which pretty much never happens anymore. So there is our cool triangular loft. I'd say that that is pretty awesome. Let's save this. Fuck. So let's continue working on this now. I want to change my profile here. In fact, I'm going to delete my loft, right? Just stand on loft in the tree and delete it. I'm going to highlight my sketch 2, and let's edit that. First off, let's delete everything. Now, for simplicity's sake, let's make a rectangle. And let's import something, right? So we're going to project a sketch. I want a reference figure of this line with maintained association as we went through. And we'll go with a coincident. We'll choose this line and this endpoint. We'll choose this line and this endpoint, right? And that ensures that my box is the same height as my triangle. And 12, right? So deactivate that. Let's do a loft and just see what it looks like, because we have 4 elements going into 3 elements. What's this going to look like? We're going to do a loft from here to here. As you can see, this little extra sketch element is kind of absorbed just halfway in. So you have 2 elements that converge into 1 element, and you can see that seam as it goes in, right? That's one of the things that we're talking about as to why you want to have the same number of elements, because we don't have that much control over where the seam ends up. If I had 2 lines right here, I could change the length of both the lines and sort of control where this little extra seam ends up. You know, add something like 10 over here. We can get a really interesting shape. But again, I might want to have more control than something like this. So what can I do to control this? And what can I do to control this seam? Let's say, I mean, you'd really want to use the same number of elements, but let's make a case here where maybe I have to go to 3 elements. What are my options? Well, first off, I have the ability to make planes, and that is extremely useful. So I'm going to delete my loft here. And I don't need my center line anymore because we've used that, been there, done that. Let's make a plane that intersects with this sketch. Now, first off, let's go to my triangle and edit that sketch. And this is a good example of when we want to use a driven dimension, right? I can take this and dimension over here, and I can see that I'm vertically 5.773503. So I can choose my plane up here, and I can make a plane that same distance, 5.773503, I think it is. Okay. So close that. And yep, our plane intersects the triangle right there. So now I can choose, and we're not seeing our rectangle feature yet, right? And so if that ever happens where something disappears, I can take this bar and drag it back down and my rectangle sketch shows up. Or I can just click up here and say generate to last feature. I can take my plane, I can create a sketch, and I can import some sketch elements again. All right, first off, I want to import this, which marks the center of my triangle with maintained association. And notice I forgot to make it reference. I wanted to make it reference, so I'll right click and convert to reference. Next, I can actually do the same. Import this guy with maintained association, and again, got to make a reference. Okay. So let's say that I want to choose an arc, and I start drawing it from way over here to here, right? And I'll choose coincident, and I'll select my little reference and my arc center, and I'm fully defined. So I'll deactivate that sketch. Let's do a loft from here to here. And this time, I want to choose a guide. And I choose a guide. Let's choose global. And I'm going to choose this line as my global guide. And as you can see, it changes the way that my edges interact. Now my seam is on this side because a global guide makes the seam go to the top of the triangle, right? My seam is completely following that global guide. So Libre compensates and chooses to put the seam over here. Now if I choose local, it might look the exact same, but not quite. You can see that my profile shifts around a little bit. A global guide is to say that the entire profile is going to be bent like this. If I choose my top view up here, my entire profile is following an angle, or an arc shape rather. But if I choose local, then we're saying that only this seam is following this arc shape and everything else is acting the same. So there's a difference between global and local. Is this guide curve that I just sketched out acting on the local part or on the entire part? It's your choice between global and local. Tangent, you can see it changes it still. And I explain tangent a little bit more in my lofting video. And finally, center line doesn't apply because you need to have it go from center to center. So I like local myself. I'm going to say OK. But we still have this problem where we have a seam going through the middle. And we set out to solve that problem, and we haven't, right? So I'm going to delete my loft. Let's solve that problem now. I'm going to sketch on the same plane that we were sketching on before. And maybe I'll choose a spline just to be a little bit fancy. But actually, before I do, let's project a sketch. And let's project our line here and our line here. We'll make them as a reference with maintained association, as we've talked about. And let's go to the top, and I'm going to make my spline. Right, we're just going to be real fancy and come up with kind of a fun spline path, except I did attach my spline to the wrong side, so let's do that again. Here to here to here to here, and I'll move my spline to the middle, right? So I've got this sort of crazy, wacky geometry. Ooh, that'd be fun. So I'm going to deactivate my sketch. Now I've got two guide curves. Let's go to loft. We'll go from our square to our triangle. I'll choose my guides as local, and we'll go from here. And then I choose a second local guide to here. And now you can see we basically are going from 4 to 3 faces in a very graceful way. We don't have a seam that's going straight to the middle of one of these lines, right? All of our seams are pretty well controlled. Now I can make these global if I wish. And you can see what global looks like. One side follows one side and the other side follows the other side globally. So likewise, I can make a plane down here and make my own guide curves and kind of control every seam going to every other seam. Very, very, very powerful what Alibre has done. Obviously, since I'm using guide curves, I can't really minimize any curvature. I probably can't simplify, but you can see we've done pretty well with some of this lofting. So when I go to loft, hopefully you can see the very intense implications of usefulness. So if I pull up my airplane, this is a lofted body. These wings are lofted. This canopy is lofted. If I go through the history of how this is made, which I will, I haven't shown you how to do this bar yet, but I move this bar to the top, and I can kind of rewind how I designed this. I go to this loft, I go to my view tab, and I show my sketches, right? This whole body is just going from one sketch to another 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 sketch. And I just do one big loft between all these sketches to generate the body of this airplane. And then I loft out the canopy, right? You can see from there, I have no canopy, and then I've lofted my canopy. And I just do a series of lofts on this plane along with other revolves and extrudes and other features, and it starts generating something that looks like a plane until I'm done. So I lofted this intake here. You can see almost everything on this plane is just ways of doing lofts. So hopefully that's a reasonable illustration as to how useful lofting can be. And if you wonder, yeah, all these sketches are on planes. And so if I go to my view and I show the planes that I've made to make this, you can see all the different planes that have helped me loft from one place to another. So lofting is so useful for making things that look realistic. And you don't need to know any of these skills other than what I've just showed you to make these lofts for this airplane body, which I think is super cool. So that is lofting. And that's probably the most complicated thing that we're going to go through in this video, mastering lofts. So hopefully that has taken something complex and made it relatively easy, which is kind of my overarching goal in all the videos that I make. Let's go ahead and do a save as. And all this will be downloadable from my GrabCAD, of course. Let's start a new part. What if we wanted to make a bolt? Well, let's make something kind of like a bolt. I won't go into all the standard thread dimensions or anything, but I can create a circle, right? And I can create a line. And we're going to say that this will have a 1-inch diameter. That'll be a really big bolt. And we'll deactivate that. And we'll extrude. 5 inches is great. Now, we don't just have to choose planes to sketch on, right? If I have a planar face like this, a perfectly flat face, I can choose Activate a Sketch, and I can sketch on that face. We'll choose our, as Tim Allen calls it, 6-sidegon. That was a funny show. I love that show. We'll go close. We'll say horizontal. And I can give this a dimension, maybe 1, right? We'll deactivate, and we'll extrude again. And there's 0.5, right? So adding a dimension of 0.5 and just saying enter, we have a bolt. But what do we do about the bolt thread? Well, let's choose our YZ plane here, create a sketch, and I'm going to sketch a triangle. And bolts are something like 60 degrees in their threads. So we give this a 60 degree. We're going to choose equal. And let's make all 3 of these lines equal. Actually, that's even over constraining it, so we don't have to worry about that. Let's import. All right, project a sketch, this little bottom line here. We're going to maintain association and make it a reference figure. And that gives us a nice little landing point to land that bolt thread profile. We'll choose coincident and make it coincident to that little end line. And then I just have to give it a dimension. So I'll choose my dimension tool up here. And we'll make this 0.125. Sweet. So I have a fully defined sketch. We're going to deactivate it. And now we're going to choose our helix feature right here. So I choose my little thread profile. And it asks, well, what is our axis that we should rotate around? And right now, Libre thinks we're rotating around this axis, which makes this really cool looking little ribbon thing. I actually really like the way that looks. But we want to change it. So we'll choose our axis right here, which instead of reference line, we're going to choose our little vertical axis right here. Now you can see we're going straight up this bolt. And there's a lot of ways to define how you want your helix. You can choose the height and the pitch, which is what we have right here. Right now we have a height of 1.96, or no, we have a height of 9.483. We can make that a height of 5 because our extrusion was a length of 5. And we can choose our pitch. There we go. You can see our height updates. We can choose our pitch to be something like, I don't know, how many instances per inch? 10? Let's try 10. Nope. 0.1. There we go. That's looking kind of bolt-ish. 0.15. Something like that, right? That looks like a bolt. It's not standard thread dimensions, but I think it'll probably work. And we'll say OK. And then if we really want that nice tapered thread that some bolts have at the beginning, right, I can go into my activated sketch. Now we've covered revolve so far, but we can also choose a revolved cut. In fact, let's import, right? So we'll choose project. And how about I import that little vertical line, reference figure, maintained association, right? Like 95% of the time, I'm always choosing reference figure, maintained association. And now I've got that little line imported with those edges I can reference. And maybe I can choose a nice little taper. It's not pretty yet. We're going to say horizontal. And I'm going to choose, hit escape a few times. We're going to choose vertical here. That didn't work the way that I wanted it to, so I'll give this a dimension. 0.15, let's say. Ah, that's why it didn't work, because these lines are equal. So that's an auto constraint that came in. I just simply click on the equal constraint and I hit delete, and then those constraints go away. I'm going to choose a vertical line here. And we'll give this a distance of something like 1. Ooh, that might be a little bit far reaching. We'll see. And delete, right? So what if I want to take this profile and revolve it around this axis, but remove material? We've done revolve where we've added material, but when we want to remove material, we choose this, right? We revolve where we cut away material. And we'll specify this as our axis. So we can choose our axis here. Likewise, let's say you don't have an axis running through it, but you have a round face running through it. We can actually choose this round face right here and use that as an axis as well. And if we choose OK, you can see that we've removed material and tapered the front of our bolt. Kind of like how real bolts do. Maybe not quite, right? That doesn't look like a real bolt-ish yet, but we're getting there. So that's actually kind of a half-decent bolt. I'm impressed with what we've been able to do. So let's save that. So we've covered extrude, revolve, sweep, loft, and helix. And if I focus some more on loft, right, I can activate my sketch. I can make a rectangle. Again, best practice to fully define that for the interest of time. I'm going to leave it be, knowing that I'm breaking a best practice by not fully defining it. I will make another rectangle here. Again, breaking a rule. If I make a subtractive loft, just to give you an idea of what it looks like when I use this, right, I choose one sketch and the other sketch, and there you can see we have a subtractive loft. I can specify my tangents and take them up to something dramatic like 10. You can see we have the exact same principles that apply. Now, one of the difficulties is maybe you do need to look at an internal surface like this, and you're having trouble. We can go to the inspect and say precise section, and we can choose our plane here, our YZ plane, and apply. And that allows us to cut the part to see internal features easier. So again, that's on the Inspect tab under Precise Section. Then you just click on the plane that you wish to section the model by. Right, I can choose the central plane and choose Apply. And there we have Views. And I can close. Now, in the tree here, I have right here Precise Section Views and Precise Section View 1 that I can toggle on and off visibility by right-clicking it. So that can be a very valuable tool should you need to use it. So we can do subtractive parts like subtractive extrude, subtractive revolve, subtractive sweep, subtractive loss, subtractive helix. I don't think I need to go more into that. The subtractive features work in the exact same way that the additive features do. So I can perhaps save that. And let's start a new part. Let's make something basic now. We're going to activate a 2D sketch. Let's create a rectangle. Again, many ways to define things. If I want the center of my rectangle to be here, I can use construction geometry. Like if I want to center this rectangle, I can take two construction lines and I can make sure with the equal constraint that they are equal. And then I can use the parallel constraint and make sure that these are parallel. And now the rectangle is centered on the origin. Likewise, since there's many ways to do the same thing in parametric CAD, I'll show one more. We can take the symmetric constraint, click our vertical plane here, and click 2 points to be kept symmetric. And now this is partially symmetric. I'll grab my symmetric constraint again, choose my horizontal plane, and choose these 2 vertical points. And now with the symmetric constraint, we are completely symmetric. Right, so that should be kind of a cool thing to go through. Let's make this, I don't know, 10 by 30. Interesting enough. We'll deactivate the sketch and do an extrude. And we'll extrude that 5 inches is great. Maybe on this face. I'll create another sketch. And I'll make a rectangle. Notice I can't reference this outside, so we're going to project a sketch here. Oops. Project a sketch here, and with maintained associations. I'll make a rectangle. We'll go with dimension 4 by 1, right? Making this up as I go. We'll go to extrude, we'll go to 1. So we've extruded this by 1 inch. How about I sketch on this face over here? We'll activate a sketch. Go with a rectangle now. Let's import or project to sketch this line. All right, we're going to go with the maintained association as a reference figure because I don't want that to be part of my geometry. We'll take a coincident constraint and attach it right to the end there. And give this a dimension of something like 1 by 1.5, right? And we'll deactivate a sketch. So let's say I have an extrusion and I wish to extrude it up to this face. Well, it's kind of a lot of work to try to measure from here to here, and if there are model updates, extruding it a set distance is going to cause maintenance if I update the model. So Alibre has given us some tools that really help out with more advanced extrusions. If I go to this extrude, I don't just have to specify a dimension to a certain depth. I can change this to something like to geometry. And then it asks me what the geometry is. I can select this face. And I say OK. And we are merged completely. So it's very useful because if I come back into my original sketch and I make this, 15, something a lot shorter, and I again generate to my last feature here, then this is already ending at this face, right? If I told this to go 30 or however long I wanted it to go, and then I changed the dimension of that sketch, this extrusion would be coming way out here and it wouldn't be updating properly. That's a huge advantage, right? Some other tools, I can activate a sketch on here and I can make a rectangle and I can try to make it coincident, right? So I choose the coincident and I can choose this line and this point. You'll notice when I have a coincident and I choose an edge, you can import it for me to try to save a little bit of time. I can make this 4. How about by 0.5? How about by 1? And I'll deactivate the sketch. So another interesting thing that I can do is click on extrude and we can say to mid plane. And now, and you can even drag the arrow in the graphics display window, now it's symmetric to the plane that I'm extruding out of. That's really important because often we make things in CAD that we want to be symmetrical. And that is super easy because now it keeps a plane that I can mirror future features across. So if I put a hole on one side now, I can use the mirror that I extruded mid-plane from as the mirror plane to mirror that hole, and so on and so forth. So mid-plane is a great tool to be able to use. To next, we'll automatically try to take it to the next geometry that this will naturally run into. So I would have to drag my sketch a little bit, right? Let's go back in the tree, edit our sketch. Maybe I'll make this 0.5, deactivate the sketch, extrude, and if I say to next, there's still nothing for it to run into, so I'll hit reverse, and then it automatically just goes to the next geometry that it finds. Very, very useful. So those are some extrude tools that are very useful in coming to work with this. Finally, dual depth is also pretty cool. I can specify different dimensions on one side to the other. So I can say, make this 1.4 inches in one direction and 5.1 inches in the other direction, right? So that is to next. The same rules are for subtractive, right? So I can do a subtractive extrude with symmetry and up to next and so on. So this is our model so far, and there are now some direct type editing features that I can do. The first one is fillets. I really think fillets are very important. So if I click on this fillet button, a fillet means a rounded edge. You can see here we're defaulting to 1/2 inch, which is good for our model size. So if I select an edge, you can see it automatically rounds that edge off. And I can continue selecting edges all the way around. Now, I can select a face, and that will fillet every edge on that face, like up here, right? You can see the fillets that we are adding. Very, very useful. So those will round edges. Now there's a really cool feature that if I don't want a constant radius that I'm rounding with, I can change this from constant to variable radius, and now I have 2 radius inputs. So I can select an edge and make my second one say 1 inch, and we taper from 1 inch to 0.5 inches. And so I can use variable sized radiuses. The next cool thing would be chamfers, right? Chamfer is what you think of as an angled or beveled edge. You can see that we just have a straight line at 45 degrees. And there are several different types. So I can adjust my sizing here, right? I can make it quite large at 0.5. I can go back and edit my chamfer and choose something like distance, distance. And that will make it 0.5 in one direction and 0.25 in the other, which is a very common way that engineers dimension these fillets. 0.125, right? You can start to, and you can also flip the dimension here. So very, very common way to do fillets. And then equal distance, right? Covered that. Angle distance is the last one. I can say 0.8 at, let's say, 5 degrees. And now we just have a very shallow 5-degree angle that we're going off of. So several ways to define a chamfer. I think it's all pretty self-explanatory, you know, how it all works. So here's our filleted, chamfered, extruded part. The next thing that we would want to go through is shell. And shell is a fun one. Let's say that I want to get rid of my fillet here. So I'm going to delete my fillet to clean things up a little bit. Let's say I want this part to be hollow. I want this whole face to be hollow and everything here to have a set thickness. Well, I can do that, right? So I have my face highlighted. I'll come up here to shell, and that shells it hollow at a set thickness. And this menu comes up when you go to shell it, and so I can say that my standard thickness can change. And then I can also change this to shell outward if I wish, to say that these outer faces are actually the inward faces of my part now. So I have many options on how to shell. And then I can choose overrides, right? So if I wish, I'll shell inward here, and I'll say I want it to be thicker on this face. Whoops, that went to the wrong one though. So I'm going to remove selected item, come over here, add this face in. You'll notice this pocket under here as I change this thickness. You can see that I made that very thin, and there we have a very, very thin thickness as compared to the rest, 0.005. So that's how you can make, you know, different thicknesses when you shell something based on what faces that you have. All right, so we have covered fillet, chamfer, shell, and then we have scale and mirror part, which is actually pretty cool. So we have different types of scales and we have different displacements. So we'll transform about the origin with a uniform scale, and if I type in 2, I make this twice as big, right? So I can scale the part anytime I want, and I can continue to add features after the scale, which is totally great. So that's a uniform scale. Now, if I go to my scale and edit that, I can change the uniform to non-uniform, and there you can see I'm scaling it 2 times, but only in one direction, in the x direction. I can scale my factor of y, say by 3 in the y direction. And if I leave my factor of z in 1, then you can see that I leave my z dimensions the same. But things can be scaled non-uniformly, which is super cool, right? So I have that scaling feature. And then if I edit that, I can choose mirror. And I don't really have a very convenient plane to mirror across. But if I mirror across the XY plane, then you can see that I change the way that the part is mirrored. So I can roll my history tree back down to prior to the scale, and then I can roll it forward to remirror it. So I don't know if I've talked enough about the history tree, so I'm going to go through that. Right. So I have this bar right here, and what I can do is I can say, well, my first thing I did was an extrusion, which meant making a sketch to generate the extrusion. Then I made another extrusion to make this part. Then I made another extrusion. Then I made another extrusion. Then I did fillet. I did an edge chamfer. And I can take this bar and roll all the way back. That's to my first extrusion. Right, that was my first extrusion. And then I can roll it forward one and see that that was my next extrusion. Then I can roll it forward by one and see that was my next extrusion, right? So this is the history of how the part was made. And you can roll it back, like going back in time, and roll it forward again to see the features that you've made. Very, very useful, right? That's what makes it parametric CAD. This would not be parametric if it wasn't for this history tree. So, we covered the history tree. We've covered all these kind of direct editing features. If I wish to change the color of my part, right? Sometimes, and you may think, well, what's the engineering application of changing the color of a part? If I'm an engineer and this is just for manufacturing, why do I care what the color is? And one cool thing you can do is if you have obsolete revisions that you don't want to be mistaken for current production parts, you can make your obsolete parts this sort of terrible, awful, no good pink color, like Pepto-Bismol-ish, unpleasant color that nobody's gonna mistake for a production part if you use that kind of coloration. Super, super useful if you ask me, to be able to change the color. But there's a few other things that you can do, right? You can change the color of edges. If for some reason you think it would look good with, oh, how about green edges? That's even more terrible to look at. But you can customize your part color and your edge color. Get that pink away from me. Ugh. Maybe I want a darker color, right? So I say OK. And notice I have opacity and reflectivity settings. And I can adjust those. So I go to my part color. I set my reflectivity to go from 98 to 100%. You can see how much reflectivity that changes. So we can play around with different opacity and reflectivity settings. Right? Opacity, of course, is you could call that transparency as well. So you can kind of see through the part if you turn your opacity down, as you're seeing here. And as you change your reflectivity, you can kind of see in the preview what that does. So that's pretty cool, right? There's our opacity and reflectivity settings, and then we can change the color of individual faces. So if I open up my face color, this menu pops up and I can make this face say green because that's actually my favorite color. And I have this pleasant green and black looking thing. So it can help you customize your appearance. And I know that Gripen that I modeled, all this is just different face colors, and it really adds a lot. You know, if I roll this back to before I assign the colors, then you can see it looks a lot more plain and a lot less exciting. So I really like the idea of using face colors, and I think it's quite useful. All right, linear patterns. Let's save this, and let's start a new part. On this one, we'll choose this here. Activate a 2D sketch. We'll choose a rectangle. I think I already showed how to center rectangles, so I'll simply use a quick method, collinear with my construction lines, and equal, right? This should be familiar because I think I just did it. And then I'll grab a dimension here and make it, I don't know, 6 by 4. Good little aspect ratio there. Let's deactivate the sketch, extrude, and we can make that 1 or something. Select one of these faces up here. We'll create a sketch, and I'm going to choose a circle. From this edge, we'll make it 0.25. Likewise, 0.25. And we'll give this a diameter, let's say 0.35. We'll deactivate the sketch. We'll choose Cut Extrude. And I'll choose Through All. I guess I didn't cover that, but that means that you go through absolutely everything, the whole model. Next, let's say I want to make a whole bunch of holes. Sketching all of those out is not very ideal. That will take forever. So we have some patterning tools that will help us out. We'll go to Linear Pattern, and when I choose Linear Pattern, this menu comes up. And it asks me what features I want to pattern. Now I can choose the hole that I'm wanting to pattern, and I can choose my linear path, let's say in the direction of this edge. I can also choose in the direction of a plane. Well, maybe not. We'll just do the edge. And then I can choose spacing. Let's say every ½ inch, I want to have an instance of another hole. And then I can choose how many instances I want. And the more that I click up for the number of instances, the more holes appear, right? Now I can also choose in a second direction a linear path, say in the direction of this edge. And I can choose a spacing of 0.5 again. And I can up the number of instances that I have. Now they're not showing up, so I'll choose Change Direction. And now we're going in the direction where we'll intersect the model. And I can make an array of holes. One thing about patterns is that they are very heavy. And the more you pattern and the more instances that you place, the heavier, and I mean computationally heavy, the model becomes. So use patterns sparingly if you can. Okay. So there we have ways that we can do linear patterns, right? We can pattern them down linear directions, and we can do 2 directions at once, and it makes this kind of cool. Great. Maybe I'll save that. And then if I delete my feature pattern, right, delete that, and I'll delete my extrusion. Or in fact, you know what, I'll edit my sketch instead. Let's make this something like 3. How about 2, actually? And I'll make this something like 2 as well, a little bit closer to the center. Deactivate my sketch now. What if I want to make a pattern of holes that go in a circle around my center axis? For that, I can choose Circular Pattern. This is my circular pattern menu that comes up. And I'll choose this as a feature to pattern. And I'll go to my center, and I'll choose the axis running through the middle of my part. And then if I change my instances, watch what happens here. Nothing seems to happen as I up my instances. And that is because I am constraining this to say I want an instance every 90 degrees. If I said I want an instance every 5 degrees of rotation, you can see I'm almost making kind of an awkward slot shape because my degrees are so low. But I can up my degrees, and you can start to see how this works. We go every 25 degrees there's a new instance. But what if I just want to have it be equal spaced? I'll choose 360 degrees. And I'll choose this option here, which is to say the more instances that I add, the more they will be distributed through the degree angle that I specify. So in this case I have 15, and go 16, 17 holes all around this circle. And I can say OK to that. I can make a plane if I wish, and my plane, in fact, allow me to edit my sketch. I'll edit my very first sketch here on extrusion 1, and we'll make this something like 14. And let's go with 100, right? Something big. We'll deactivate the sketch. And notice my tree goes back to where I've been editing. So I can either drag the tree back down to regenerate the features that I've made, which of course come down here. So if you're wondering how we got here, right? Record scratch, that's me. I bet you're wondering how I got in this situation. What we've done is we've said we're going to make a hole pattern from this hole, which was defined from this face and this face. So we've got a hole right here, but we're still trying to pattern it around this center axis. And so the pattern is going whew, all the way around, and it's very, very, very big. So we just have to run a simple update. And this goes back to design intent, right? I should have dimensioned this hole closer to my axis, because then as I updated the model, it would have updated in a predictable way. So let me take this dimension, delete it. We'll take this dimension, delete it. I'll take a new dimension, and I'll make this horizontally, say 2 inches away from my axis here. And maybe I'll take a horizontal constraint and make this hole be horizontal. And then if I deactivate my sketch and generate to my last feature, you can see that brings back our hole pattern. So when you're doing parametric CAD, that's very, very, very common happening, where when things update, you just have to run through the tree and figure out why something didn't update in a predictable fashion. In this case, I dimensioned the edges instead of around the center axis. All right, so if I get to the meat of the thing, I could do a linear pattern, and I can select my feature pattern and my original hole, and I'll choose this linear pattern to be in this direction. And you can see patterns are heavy, so we're thinking about this already. So depending on your system performance, right? Oh, that looks really cool. Depending on your system performance, you may have had a hard time regenerating. Just let it sit and do its thing, and it will happen. So I can make this, be spaced out we're at every 5 inches, or every half an inch. Let's go every 5 inches and update that. Again, we have to stop and think about this. And so we can pattern our patterns doing this, which is super cool. So I say OK to that, but why stop there? What if I want the other side to be patterned? Why? I can model, and then I can choose this mirror feature, right? So when I go to mirror something, I think I mentioned mirroring earlier. I can take everything that I've created so far simply by clicking on it, and I want to mirror it, say, across this plane. And it's a lot like the symmetry constraint that we've been working on. Now, I just created a heavy pattern over here, so it'll take a minute to generate the pattern on this side. There it goes. I can say OK to that, and you can tell by mirroring it, I've put a hole in between every other hole from mirroring this around the center. So you can omit that from your mirror if that's undesirable, but this being a basic example, I think it shows that you can pattern patterns to probably an unlimited degree, and things turn out really beautiful. So we can create patterns, we can mirror individual holes and extrudes and everything, and it comes together very nicely. So I have a tutorial on making a JAS-39 fighter jet. I think it's one of the coolest fighter jets out there. And I used a picture to help me model that. And so you can import pictures if you wish. You can check out my JAS-39 series if you wish to model from pictures into greater depth. Here, I'll just show you how to import an image. So let's start a new part. I can save this. And here's our new part. I can choose my tracing image. And my plane, I'll just choose this as a plane, and I can browse through the Explorer for my image here. And there, my image is imported. I can also choose my scaling, right? I can make this say twice as big, but of course it only goes twice as big in one direction. So I can edit my tracing image from my tree here, and I can put a 2 on my Y scale as well. And I can twist this at an angle if I need. I can also edit the position with my X and my Y offsets. Importantly, I can calibrate my size. Let's say from center to center of my wings. I think that would be like 3,600 inches. Then I can scale my image up to that size within my program so I can get the exact dimensions that I wish and make whatever I'm making in scale. And then I can trace sketches around this plane and start modeling from it, which I go into great depth with in my JAS-39 video where I model this thing. So there we have a sketch picture. We have some datum geometry as well, and I think we've gone through some of it. Let me close this, and I'll reopen this guy here. So I've shown you how to make planes, and I can continue with that, right? So if I want to make a plane, and I can choose 3 points to make a plane off of my solid here, and there's a plane, so I can sketch on that plane or do whatever I need if I need some additional reference geometry. Or I can choose this edge and 1 point, and the plane will say spin around this edge and intersect through this point to fully define it. So I can make a plane that way. Or I could choose this curvy edge, and I can just make a plane that is constrained at the end of the edge, and I can choose the other end. And what I'm doing, right, is I'm saying I want the plane to be normal to my edge, or I want the whatever curve is on my edge to be piercing straight into the plane as it's constrained. So this ends on horizontal, right, where this is, I guess I should say this edge ends on being completely vertical, so the plane is exactly horizontal because this ends on being exactly vertical. And if I go to the other end, you can see the normal that this edge ends on. So we can make it on the end of edges, which I think is super convenient. And you can go along a sketch with the plane as well. If I choose a closed sketch, and I choose along a sketch, right, I can choose the percentage that I want my plane to be along it. This isn't that great of an example because it's so hard to visualize, but Libre is doing this in a good way. So if I close this, right, and I sketch on this face, and I create a spline that's just kind of a crazy shape, and I deactivate my sketch, and I grab my sketch and I grab my plane and I progress my plane, you can tell that the plane stays normal to any point of the sketch that I say, from 0 to 100%. So I can do a plane definition anywhere on a sketch, which is super useful. We've done 3 points, which I've shown. And here if I create this plane, I've got a tangent slope, which is pretty cool. So if I have a curvy surface like this curvy face, and I create a plane, I choose this plane that we're going to be tangent to, and I have so many planes on here it's getting confusing. So I can make the plane tangent to this edge, and then I choose a reference over here, and you can see that the plane is parallel and to the plane that I chosen as a reference, and tangent to the curvy edge that I made. I can reverse this if I wish for it to go to the other side, or I can delete my plane reference, and I can say, oh, you know what, I want you to be parallel to maybe this plane, and then it's parallel to that plane, and I can reverse that plane up and down, right? So that is all these ways that you can generate planes. And fear not, because all these planes, of course, are in the history tree parametrically that you can adjust as time goes on. In some people's workflows, they create planes for every single sketch that they make. And the benefit of that is you can adjust the position of any sketch at any time. So it can be a reasonable habit to get into. And it especially works in Alibre. So in some platforms, that is even a best practice. I don't know if making a plane for every sketch you make is the best practice in Alibre or not, but I think it carries some benefit either way. So I'll save this. So on the model menu, I have covered just about everything except this equation editor. This is new, or I should say this has been updated since the older version that I've been using. So I'm not brilliantly familiar with equations yet. I'm just familiar with the old way that Alibre has done them. So I'm going to hold off on covering this until I get a chance to really practice it. Other than that, we can change this to regenerate everything, and that just regenerates the whole model from start to end, versus you can say generate to last feature, which there's not a lot here, so it generates really quick. But again, I can skip down here and say generate to last feature, and it regenerates everything. I can come down here and say regenerate all, and it regenerates everything. So there's similar functions. This just generates everything from the beginning, whereas the other one just regenerates from where the bar is the only difference. So great. We've covered sketching, we've covered extrude, revolve, sweep, loft, helix, extrude, revolve, sweep, loft, helix, fillet, chamfer, shell, scale, mirror, colors, patterns. Maybe I want to make an axis. And just like in planes, this should feel very familiar. I can make an axis from one point to another, which is, of course, in Alibre called vertexes. I choose 2 vertexes. That gives me an axis running through the part, right? That's an easy way to generate something that you want to make a polar pattern around. I can choose an axis around a curved face, right? So now I have an axis that runs through the center of my curved face up there. I can make an axis from 2 planes that intersect. So I have this plane intersecting with this plane, and then I have an axis that goes through where those planes intersect from, right? Easy. So there's 2 points, intersection, curved face, plane face normal, and point vertex. So I can make this face, and I have to actually highlight this to be able to select a point. That threw me for a second. Then I've created an axis normal to this face at this point that I've selected, right? Easy. And then I can just choose a straight up model edge, right? So I can choose this edge, and it turns that edge into an axis. So that's how you make axes. And now you can make just datum points. And you can define points just by where things intersect, like how our origin is, where 3 planes intersecting. and so on. Now, I have not used points, and they haven't been too needful for me to use at all up until this point, but you can make them through similar means as axis and plane. All right, so I think I have covered just about everything, and I promised that I would do a little bit on assemblies. So let's open up a part. This is a guitar body that I've made, and if it gets too busy, right, because there's a lot to look at with all these planes and sketches that I've made, I can adjust my view to hide. All right, I go to the View tab up here and I hide sketches and I hide references. And that should be just about it. Our view's cleaned up. If this is too boring of a color, I can change my color to some, I don't know, cool electric guitar color. We're going to say OK. Kablam, right? That's kind of a cool, energetic color that you'd want to do a guitar solo with. Let's now say File. So let's take a Libre and make a new assembly here. And this opens up the assembly environment, which is a little bit different than the part environment. It may ask you to import parts immediately. If it doesn't, or if you need to add parts after the fact, just say Insert Design right here. And I'll take my guitar body, and you'll see I've got a little menu right here that says Inserting. Each mouse click will add another copy, so I can just keep on clicking my mouse and add as many guitars as I wish. That's pretty busy, so I'm going to say Finish. And of course, if I'm assembling a guitar, I only need one, so I can select my tree. I can hold Control and select all my bodies and say Delete. So this is free to move around. My first thing I like to do is right-click and simply say Anchor Part, and that means that I've got at least one part in my assembly that is fixed in place and won't float around. You really need that. I can say Insert Design, and if you wish to follow along, you can download this in GrabCAD from my GrabCAD account. Maybe I want to add some knobs, right? Nice little adjustment knob. So I'll add my adjustment knobs now. Now, of course, this is turned and weird, and I just want this to fit where the knobs go. So if I highlight this face and I highlight New Constraint, right? We use constraints a lot like how we use sketch constraints, and we can make these things related. So I want this face and this highlighted face here to be what we call coincident or resting on each other. But as you can see, this became coincident in the wrong direction. So first off, this defaults to coincident, and I can flip this part around and apply. And there you can see, no matter what I do, this knob is always going to be coincident to that face. But I want this knob to be in the middle of the circle here. Well, fortunately, I have a circular face in here. So I choose my circular face, I'll choose New Constraint, and I'll add in my other circular face, and we default to being concentric, or coaxial I should say, where they share the same axis that runs through the circles. So I can apply that, and now I have a knob that twists just right. 1 degree of freedom, we would say. We can do the same. Right click here and here. I can flip this around. I can apply, and then I'll choose my circular face. And I'll choose my next circular face, and our knob is positioned. And a final time, we'll reverse, we'll apply, circular face, circular face. So those are some decent ways to get started. What else can we do? Well, how about I import my guitar neck? I'll insert design. And insert my neck detail and finish. So the first thing, I know that I want to add a new constraint and flip this thing around, right? We're going to be, this face and this face are going to be coincident. We flip it upside down. There we go. Next, what if I want things to be a certain distance apart? Well, I can select this back face, and I can select this face over here, and I can change this to be offset. And I can make my offset something like 10 inches. And apply that, and now no matter how I manipulate this, those faces will always be 10 inches apart. Now if I want to change that again, of course, I can view my list of constraints here, and I can find my offset constraint, and I can edit that. Likewise, I have all my parts here, like my guitar body, my adjustment knob, and so if there's a lot of constraints in a very long list, I can come down here to my neck detail, and I can choose my constraints down here, and then I just have the filtered constraints for my neck and not for any other components. So it's an easier way to find your constraints. In fact, I recommend using that way to find constraints because this list gets pretty long pretty fast. But what if I want these faces to be parallel? Well, there's no parallel constraint, so Libre can't do it. End of story. Just kidding. I set my angle, and notice it will hold whatever angle I wish, 45 degrees even. So all I actually have to do for my angle is set this to 0 degrees, or in our case, 180 degrees, and say OK. And now it makes sure that they're parallel, but I can still have any distance that I wish and constrain it in other ways, should I want to do so. Now, I know that I have a bolt hole right here, and the bolt should thread into this hole. So can I constrain those? I'll add a new constraint, add my hole, and of course we have an angle between these, which isn't what we want. So I'll change this back to coaxial, and again our coaxial constraint delivers. So I can apply that, and you'll see that no matter how I manipulate my neck, we are now fully constrained. And I built my guitar. So those are the fundamental constraints that I like to use. I have more on Libre assemblies in my guitar series. You're welcome to check out my guitar series to learn more about assemblies, and Libre offers some really awesome assembly features that is worth checking out, like in-context editing, which I also go into in my guitar series. So this has been quite a lot of material. I hope that it's been enjoyable. I hope it's been helpful. If you made it this far, I am proud of you, and I think that you are an awesome person, whoever you are. It's been real, and please subscribe, and I'll see you in the next video.